Hello everyone. Um, Welcome to this short feedback session on homework 1. I know that you have the exam a bit later, so I hope that you can focus here. Yeah, the exam later anyway is more, I think, to help you prepare for the final exam. It's only 1 or 10% of the mark, so I hope you don't worry too much about it. The idea for right now is that I want to go through my code as a sort of reference solution for the homework 1, and then maybe I can show you a bit how things could be solved. It's one possibility among many, but I hope I can give you some tips and tricks on how to solve different things. I already had a quick look at all your homework assignments, but I haven't marked yet, so I'm also hoping to take into account what you have submitted to show a few places where things went wrong for some of you and the things that went very well for some others. So yeah, maybe let's get started with that. Okay, actually this might be very small. Let me change the size here. 22. Okay, this is okay, I think this should be better. I hope that you can see this well. If you have any trouble or have any questions, just post something in the Twitch chat. I'll reply. So there were a few key steps in the assignment, and the first one was to read and parse the file. There are different ways in which you can do this. This is maybe the sort of easier option, even though it's not the most, yeah, it's not the fastest. So you can use just the options from the standard library. If you use an input stream and if you just read things line by line, you are basically getting either one vertex or one face from the obj file. And then, yeah, what I use here is string stream. This is rather slow, but since we are only dealing with a pretty small file, it's not that important. String stream just takes a sort of another input stream, and then you can get elements from it as if it were a file or anything else. So based on that, you can get different words where words are separated by white space, so either spaces or new lines or anything else. And that's where you can easily get elements, like this thing at the beginning would get whether you have a B for a vertex or an F for a face, and depending on that you can do something similar to get like all the coordinates of a vertex, or to get all the indices of the vertices of a face. I think that was pretty easy, so none of you really had trouble there. Then the next step was actually to create a grid of voxels. I think most of you used the struct that I provided, so there you only had to initialize it with the number of rows in the X, Y, and Z axis. So for that, you basically had to compute the range, so the difference between the minimum and the maximum coordinates on the X, Y, and Z axis, and you divide it by the voxel size afterwards here, so something like this. The range divided by the voxel size. The best option is just to use the ceil, the ceiling function, to round it up to the nearest integer value. Here I'm using a small trick maybe. When you're working with voxel models, it's many times easier to work with algorithms that assure you have nothing on the boundary voxels. So I just decided to increase everything by 2 so that we can have an empty voxel like in the top, bottom, left, right, front and back. So one row that can be empty. This is just a suggestion. For this assignment it doesn't make a whole lot of difference, but it can make things easier for you when you're working with voxel models. And then I just initialize the voxel grid using the number of rows that I computed. Yeah, what else? For the voxelization of the boundary, so here it was basically the implementation of the intersections with the 3 intersection targets, the horizontal, vertical and back to front targets. And in order to do this, I think a lot of you initialized some sort of a small data structure like consisting of 2 endpoints, and then you could reuse your code with the 3 intersection targets. Some of you decided to hard code these 3 tests. I think this is fine for the assignment, it's not a problem, but let's say if you wanted to do like a more expensive computation or something more difficult, like if you wanted to compute things for 6 connected voxels, then there are no longer 3 intersection targets, you have 12, and then the hard coding becomes a lot messier. So ideally you could have created a small data structure to store these endpoints. Yeah, so going through my code here, I think the key thing here in terms of optimization is that it's a lot better to do a big iteration over all of the triangles, and then for every triangle you compute the bounding box of the triangle, and then you iterate only inside the bounding box here based on the small bounding box of the, here you iterate over the voxel grid only in the bounding box of the triangle you computed. This is a lot faster because you can imagine that triangles in general are very small compared to the whole voxel grid. So for every triangle you're iterating over maybe 10 or maximum like 100 voxels rather than over the million voxels you might have in the whole voxel model. So this is the single biggest optimization that you can do for your code, and this is only possible to do if you do the iteration over triangles first, and then for every triangle you do the iteration of the voxels. Some of you did it the opposite way around, and then even though it seems like an optimization, and it is, you are still going through every single voxel for every single triangle. And even if the only thing that you're doing in the voxel is just doing like a small if condition to check if you are within the bounding box or not, this is actually very slow. So my advice would be to do the iteration over triangles, and then you do the iteration over the voxels only for the bounding box of the triangle. Yeah, here is the point where I'm defining the 2 endpoints of the intersection target, and I'm reusing the intersects function that I sort of provided for you as a skeleton without the code that is inside, so that you can reuse the 2 endpoints that you have created. I think this is the, I mean, it's not perfect. Maybe you want to put all the endpoints in a list so that you can add as many intersection targets as you want. That's a more reusable option. But for 3 intersection targets, this is something easy that you could do. One other small optimization that some of you did and some of you didn't is that as soon as you find one intersection you can stop the process. You know that the voxel is full, so you don't need to keep checking the other targets there. Many times if you have something like a sloped surface, so something like the roof of the building, you will have all 3 or maybe 2 of the intersection targets already crossing the triangle, so you can stop the process as soon as you can. One other optimization that some of you did that I actually forgot to do was to check whether the triangle, whether a current voxel was already full because of an intersection with another triangle. This is something that you could have done like somewhere here once you start inside the iteration. So if the voxel is already full, you don't need to do any intersection tests. You know that it's actually already full. What else for this part? Yeah, same as for the previous part of the code. I think one key function to use is the floor function and the ceiling function. So when you compute the bounding box of a triangle, you want to make sure that you cover also the voxels that are partially intersecting it. So for the minimum, you might want to use floor to round it down, to check also the voxels that are a little bit like to negative side, and ceiling to check also the voxels that are a bit on the positive side. So this is a very common thing in geometric computation. So if you want to get a slightly bigger window, sometimes you do like the floor for the minimum and the ceiling for the maximum. Another interesting thing is what do you do with edge cases. So if you a lot of you created the voxel grid in a manner that you use the absolute minimum of your original mesh model for the minimum of the bounding box. In that case, you will have the case that the whole bottom of the faculty building was perfectly aligned with the voxel grid at 0 meters in elevation. This is rather an interesting case because that means that when you do your intersection computations, the intersection target will actually be perfectly touching the bottom. So it will not be intersecting, it will be just touching. Some of you might have noticed that when that happened, the whole bottom of the voxel grid was empty, the whole bottom of the building. So you had something like a hollow model where you might actually, when you do the flood algorithm, you might get into the model from the bottom, something like that. Yeah, that happens because of the intersection tests when the model is perfectly aligned to the bottom. I just did a very quick solution for this. So I recentered the model, not to be perfectly aligned to the minimum of the bounding box, but I actually centered the mesh on the voxel grid. This is generally a good idea because it produces like nicer looking voxel models. And you are not dealing so much with edge cases. Some of you decided to do something different, like you treated the bottom layer differently. You filled it perfectly if it was on the bottom layer because you know that the bottom voxels are totally full, unlike the boundary voxels, which we said we have full, but we will get to that in a moment. Yeah. Another nice possibility that I think none of you did, but I have only checked the things quickly, is rotating the model of the faculty building. So many times you want to get prettier models, you want to rotate them so that they're perfectly aligned to the axis. because things just look nicer. You can get actually more accurate computations sometimes, but it's not important. It's just one suggestion that you could do. So let's go to the filling part here. So for the fill, my suggestion was to use something that was, is outside the model. So you could pick a voxel anywhere, but since in this particular model we only have like this single big tower from the faculty building, and it's nowhere near a corner, if you pick a corner voxel on the top, you could easily make sure that you were outside the model, and from there you could do a fill of the whole of the exterior with a different value. Some of you used actually recursion for this. If you use like standard recursion on the stack, you will have a lot of problems because you might have like a million elements or more in the stack, and then your code will crash. So there are a few alternatives for this. You could use something like what I did here. So you create your own stack as a data structure and you manually manage it. This is serves as a sort of bucket, so you throw in it things that you need to check, and then you can go through the elements of the stack one by one. For every element you check all of its neighbors. That you have 6 neighbors here, and as long as you're not on the boundary, you just add all of them as long as you're not crossing a boundary voxel. Some of you had code crashing because you were not doing these checks. So like if you're going left, for instance, you might want to make sure that you are not at the leftmost part of the voxel grid. And if you're at the right, you need to make sure that and if you're going right, you need to make sure that you're not going to, you're not in the rightmost part of the voxel grid before you add the neighboring voxels. This becomes a bit tricky sometimes with the logic of the code. So I think some of you either, not in the final submission, but you were struggling throughout the process. I talked to some of you. For the rest, yes, use your own data structure. It doesn't have to be a stack. It can be a queue or it can be anything. Check my notes here. Yeah, so I think if you start Googling for answers to programming questions, you will find the website Stack Overflow. So a Stack Overflow is what happens when you work on the stack and you fill it and your code crashes, like you could easily do in this case. What else? Another thing that could make your code easier is this. So some of you try to use the same value to mark the exterior, the interior, and the boundary voxels. This is possible if you do some manual management, but it's a lot easier to just set a specific value that represents the exterior, a value that represents the interior, and a value that represents the boundary. I personally use 2 for the exterior, 1 for the boundary, and 0 for the interior, because it's just what happens when the filling algorithm is done. So I had like 2 different things that I was counting. At the end of the float algorithm, I counted how many voxels were actually filled, and how many voxels were on the boundary. Yeah, this is where I actually did some manual management just to get a quick result out. Yeah, so for the computation, the suggestion that I gave you in the assignment page was to count voxels that are on the boundary as being half full, which is different from the voxels that are fully in the interior, because those are totally full. This works because of probability, actually. So if you have a large enough model and you test it with different kinds of voxel values, on average, the boundary voxels will be half full. So this is just a quick way to get a good result out. And yeah, so if I just do these optimizations and I run the sorry, I think you might have lost the video for a moment. If I run the calculations and I get everything out, I got a value like this, so like 194,000 cubic meters. The value is close to 195,000 cubic meters. I don't expect you to get a perfect result, but ideally you tried a few different voxel size values. I think if you go very small, you might start getting inside the model because of some validity issues. If it's very large, you will not get a very accurate result. So I think as long as you got somewhere between like 185,000 to 205,000, I will give you the full mark for the volume calculation. And finally, the other part of the output, for the other part of the code was actually producing the output in the form of an OBJ file. Some of you asked how to do it best. I left it a bit open so you could come up with different solutions, but ideally you created something like a list of triangles per every voxel. It's possible to just output 6 squares per voxel, but the thing is that a lot of software doesn't like OBJ files with squares or any polygon, because then it has to do like a triangulation of the polygon inside, and even though it seems like a very easy problem to triangulate a polygon in 3D, it's surprisingly messy. Even Blender doesn't do it very well if the polygons are slightly non-planar, and because we're dealing with approximate coordinates, all polygons that are not perfectly aligned to one axis will be slightly non-planar, and a lot of software just doesn't want to deal with that. So what they do is only support OBJ files with triangles. So the ideal thing was to output 12 triangles per voxel. Just for your visualization, I suggested that you could reduce the size of the voxels a bit. I just define a small factor here to reduce the voxel sizes. In that way you didn't have clashes, like visual clashes. Otherwise, when you have two adjacent voxels, you will see that one of the faces of one voxel will be the face as the face of a neighboring, like an adjacent voxel, and these will cause some issues, especially like in a lot of software you will get visual glitches, and in Blender you will get rendering issues, so things will start to look pretty ugly if you zoom in enough. So my suggestion was to make the voxel smaller. I will not deduct any points or anything, but ideally you also oriented your triangles or your polygons with the normals pointing outwards, because a lot of software, including MeshLab, if you use the single-sided shading mode, will look bad if you don't have a consistent orientation of your triangles. If you want, some triangles are pointing inwards towards the center of the voxel, and some triangles are pointing outwards towards the center of the voxel. One final thing that I suggested to some of you is that to use a temporary structure to store the vertices and the faces before writing everything out to a file. This will likely be easier because some software also doesn't like when you put like vertices, then some faces, then some vertices, then some faces, vertices, faces, and so on inside an OBJ file. Some software likes to have all the vertices at the beginning and all the faces afterwards. Yeah, so my suggestion was to do that. Yeah, if you have any questions or things that not only about this but also about the exam, just feel free to post something in the chat. One more thing. Some of you wanted to have small OBJ files, as small as possible. So you wanted to avoid duplicating vertices. There are different ways to do this. My suggestion to some of you was to use a hash map. In C++ in the standard library, there's std on order map, and that is a hash map where you can sort of compute like a hash for every vertex. So given 3 coordinates, you can say what index the vertex is. So if it already has an index, you refer to it when writing the face. If it doesn't have an index, then you do create a new vertex. That's a cheap and fast way to do the computation. So hash maps are very, very quick. So actually you could have gained some time in your computation because writing more vertices is actually slower than writing smaller files, even if you'd have to do this computation. Yeah, so thanks Jasper for clarifying that. If you need more time for the exam and have if the regulations say that you need more time for the exam, it's okay if you submit it afterwards. Just do the proportional calculation. The file request link on Dropbox will be kept open, so don't worry about it. Just take the extra time. So that's it for me. I will upload your marks for the assignment by tomorrow, more or less. And if you want to have personalized feedback, I'm very happy to provide it. I will not do it by default because sometimes some of you don't read it or don't care to have it, and then it's extra work for me. But if you want personalized feedback for your assignment rather than just your mark, send me a message and we can do a short discussion, or I can send you some clear pointers about what went right and what went wrong. All right. So if there are no more questions, I'll see you a bit later for the exam. So in 11 minutes, I will upload the file in the link, so it will be available 5 minutes early, just in case anything goes wrong. Please read the instructions, even though they're the same instructions in the midterm exam page. You just have to download the file, fill it in, directly fill it inside the file that's my preferred option. If you really want to use Word or Pages or LaTeX or anything else to write your answers, it's okay. Just upload a PDF file with all your answers. As I said, the file request will be kept open. And there's a tolerance of 5 minutes. So if you upload up to 5 minutes late, it's not a problem. If you're worried about the time, please just set up an alarm on your phone or something. But I will also post a message on Discord when the time is up, and afterwards you will have 5 minutes to upload the file. And finally, if anything goes seriously wrong, like your internet is down, your computer breaks down, anything, don't worry. Just let me know as soon as possible and we will do some sort of alternative arrangement. I think it would be like oral exam where we discuss some of the lessons. So yeah, don't worry. The midterm exam is mostly to help you prepare, to know what sort of questions will be asked in the final exam. And yeah, good luck and see you all online. If you have any questions during the exam, just send me a message on Discord or an email. I'll be checking it. Bye everyone.